I'm Martin Herbordt, and this is Miriam Leeser, and we are very briefly going to tell you about the FPGA part of the Open Cloud Testbed. Since this is a very short talk, I think I'd just like to get across. Okay, I'd like to get across maybe just 2 points, and one is that FPGAs can go into lots and lots of places in the data center, and the second is that in each of these places there is a wide variety of capabilities. So with those two thoughts in mind, let me jump right into it. So first, motivation. Oran already talked about Microsoft and how 5 years ago Microsoft made the monumental decision, especially for those in the FPGA community, to put an FPGA into every new server to do all sorts of functions, which I'll talk about in a second. And Doug Berger has given this slide deck often, and this is his view of the world, and I guess perhaps ours too. And some of the things that they are using the FPGAs for are system uses, SDN, instrumentation, and so on, internal applications, compression, encryption, and also, amazingly enough, applications themselves that they sell as a service, most especially machine learning. In parallel to this, there have been various university research programs, including ours, where we've looked at not just the bump in the, turn it on, not just the bump in the wire out here, but also FPGAs in lots of different places, which again is the first message, that we have for a long time been using FPGAs as accelerators and even as accelerator clusters. For a long time, Mellanox has had FPGAs on NICs, and for a while, are coming back now, FPGAs in the router that are even programmable for things like low latency, well, for high frequency trading, low latency trading. Amazingly, in parallel to these parallel efforts, we have Intel, who has developed an entire new infrastructure called COPA for use in high-performance computing. And Venkat is here, and I'm sure he'd be happy to tell you more about his incredible project at Intel. So we have been going around conferences for a few years talking about how incredible it would be to be able to have these things, especially Catapult, but that is everything that the MOC is. A research test bed, well, open to people who are not working, an open test bed. And the FPGA part of this project, so why do we need this? And well, as I just said, in Microsoft Catapult, we don't have user access. There are other systems where there are FPGAs available, most well-known AWS, which we all use, but these are really application platforms where we don't even have access to our hardware operating system development itself. Finally, there are a number of FPGA clusters that are developed at national labs and in academia, but again, these are hard to use, very difficult to make use of to outside, and also dominated by high-performance computing as an application. So just a quick view of some of the projects that people are doing in the data center. On the hardware side, Ahmed, in just a couple of minutes, will be talking about hardware operating system and development environment. There are also the system applications that we talked about, including privacy-preserving computation, and a whole bunch of other projects, each one of which has the order of magnitude speed-ups. Things like middleware acceleration, queue matching, other offloads. Lossy compression has turned out to be sort of an incredible application that HPC people desperately need. Massively parallel computations at the back end, and distributed machine learning, just for a few. And now I will turn it over to Miriam.
So, as Martin said, I'm Miriam Leeser from Northeastern. Both Martin and I have been working in FPGAs for a very long time, and so have a number of people in the audience. And I just, at a really exciting time to be in this area because FPGAs have become mainstream. Everybody's talking about them. So the goal of our project is, like Martin said, to make FPGAs available. We're still at the evaluation stage in terms of how and what that infrastructure is going to look like. We're hoping to get lots of input from the community, but we're really determined basically to have an open test bed that people can do really innovative things. And one of the challenges for us is how do we deliver that? How do we give people the things they want? And so part of that, and this is thanks to this NSF grant, we will be hiring a full-time FPGA engineer to work on some of this. We're integrating into everything you've heard about this morning, so existing infrastructure, which we think will help a lot. Most of the projects you've seen have been, certainly the academic ones, have been sort of one-off clusters and don't have that infrastructure. And then, like I said, the broader community is really essential to make this successful. So we're looking to all of you to make that happen. So to figure out what we should do, and like I said, we're still in our early planning stages, we went off and did a survey. So here's just a list of various universities who we surveyed. The X's are the people who responded, but we've been in this community for a while, so we went after what we consider to be sort of the heavy users, as well as some people in labs, industries, et cetera, to try to figure out exactly what people want to see done with this. So, Martin and I are the alpha users, basically. And then once we get to beta stage, we'll be opening it up. And we're really hoping at this time next year, we'll have a really nice set of users. So we asked people what they wanted. And here's kind of an overview of different ways people want the FPGA connected. I would actually summarize this by saying that no one wants the latency that you get from being an attached accelerator to a processor, right? We want to be first-class citizens on the network. Whether or not that means doing research on the network, it does for a small set of people, but really what we want is very, easy access to FPGAs, straight off the network, very fast access to data, make the pipes direct, et cetera. Here's a list of the different projects. And the answer is people want to do things all over the map, from cloud and operating system research to middleware. I know a couple of people on the list are looking at various security issues, tenanted applications, just basically almost everything. So we had 17 responses, and everyone was really enthusiastic, but I think that's a self-selecting audience, right? The people who responded were very enthusiastic. We did ask of Intel versus Xilinx preferences, and it was pretty evenly split, which is kind of interesting. High bandwidth memory is a really hot thing in some of these server cards. Half of the respondents said yes, the others didn't really reply. I don't know if those are the people who've used it already or not. And then people, didn't really care that which board. They were much more wedded to sort of the tool flow that they were familiar with. So right now we're evaluating two different options. One is an Alveo card from Xilinx. I guess that came out a little smaller than I realized. It's the Alveo 280. And the other one is an Intel card. And each of them has its advantages and disadvantages, and each of it has its proponents, and we're actually getting both in-house. We have the Alveo card at Northeastern, we're getting the Intel card, and we'll be evaluating them and seeing what's going to be involved in setting these up. Here's a very quick summary. We'll talk more about this in the deep dive, but the Alveo card has high bandwidth memory. It has networking connections we could use, but only 2 of them. Intel has more of those connections, but doesn't have a high bandwidth memory. They each have essentially their own design flow because the tools come from the manufacturers. So those are the things we're looking at. And if you want to hear more about thoughts, directions, et cetera, our breakout session is tomorrow afternoon at 2 p.m. So please join us because we'd really like it to be a community discussion about where we go from here. So thank you.